Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering. Welcome to the show. I'm Tristan Handy.
And I'm Julia Schottenstein. Today's guest is Brian Amadio, who works at the data platform at Stitch Fix. Stitch Fix is a data-forward e-commerce company, and Brian shares more about all the rich problems that his team tackles. We're going to talk a lot about experimentation on this episode, everything from A/B testing, multi-armed bandits, reinforcement learning, causal inference, and more. Experimentation is hard, right, Tristan?
I was going to say, this is the episode that we've recorded that has made me feel the most out of my depth so far, and I did a lot of learning in real time.
Yeah, it seems like hard to get right. There's often not enough data, don't have the right people to interpret results, proper isolation can be expensive. So we're going to hear a lot from Brian on how they do this really well at Stitch Fix. And it's been really cool to see the field evolve. It feels like there's more and more sophisticated techniques that both analytics engineers and data scientists can try out. And we'll really get into the edge of experimentation in this episode.
I feel like, as every good economist knows, the hard thing about experiments is when people get involved. And that's ultimately what Stitch Fix is up to, is figuring out how to do experimentation involving humans in ways that actually produce valid experimental results that you can rely on. And I think that they are absolutely at the forefront here. But even Brian in the episode admits that there are times where there's things that they're learning and trying to figure out in the process. So experimentation overall is not a field that I feel like we as data professionals have down to a science. So I'm excited to learn as a part of this episode and to continue having conversations like this as we go.
All right, without further ado, let's get into it.
Brian, I'm very excited to be talking today. Before we dive into talking about data, I want to talk about Brian as a human being. Where'd you grow up?
Hi, Tristan. Thanks for having me on. I grew up in New York State, Long Island, suburb of New York City.
And where are you right now?
Now I live in San Mateo, California.
You did the Great Migration. Was that for a tech job? Was that for college? Why'd you end up on the West Coast?
So yeah, I originally came to the West Coast for grad school. So I went to UC Berkeley to study physics. So yeah, I moved out to Berkeley. I actually chose Berkeley because of the location. I knew going into grad school that afterwards, there were two possible tracks. You could stay in academia or move into the private sector. And I knew the Bay Area would be a great place for that if I decided to go that way. So it turned out to be a good choice.
It's one of the things that I wanted to hit on with you. So you've got an undergrad in physics, you've got a grad degree in physics.
That's right.
And you are now a data scientist or data engineer. The physics to data track is I think, reasonably well-worn track. How did you find yourself going in that direction?
Yeah, absolutely. Especially the branch of physics I was studying, I was doing experimental particle physics. So my research involved analyzing huge data sets from the ATLAS detector at the Large Hadron Collider. So I was already doing big data in grad school, toying with some machine learning algorithms, working with distributed computing. So it was a pretty natural transition. Also, a lot of people come from experimental particle physics. I remember there was one year when there were 7 people who were finishing at Berkeley Lab particle physics group. And they always announce at the end, where everybody's going. And I think one person did a postdoc and 6 of them went into data science. So
you all cut your teeth on the fundamental laws of physics, and then you really hit the big time when you went into figuring out how to predict what clothes people wanted to buy.
Yeah, exactly. Yeah.
Speaking of Stitch Fix, what percentage of your own personal wardrobe is Stitch Fix? For me, it's about a quarter, honestly. I've got a lot of Stitch Fix stuff in my wardrobe.
You can lie here as well.
Yeah, good question. We used to have sample sales back when we worked in the office, quarterly sample sales. So at that time, my wardrobe was a lot came from the sample sales. So pretty high percentage, but
nice.
It's been over a year now. So that's changed.
Last thing before we dive into experimentation and everything else we want to get to. Your former colleague, Eric Colson, wrote a post that I really truly loved. It was called something like the how to avoid the data science pin factory, and really advocated that data scientists should be full stack data scientists. I'd love it if you could just explain what that means. And I know your title was data scientist for a little while. Did you consider yourself a full stack data scientist?
Yeah, actually, that factor is one of the main things that drew me to Stitch Fix, this way of organizing data science. There's really two, I think Eric talks about it in the post, but the kind of traditional data science where you have data scientists mostly working in notebooks and prototyping, and then kind of throwing it over the fence to the engineers to put it in production. And then at Stitch Fix, we turn that divide on its side, and you have platform tools built by platform engineers and data scientists who use those to implement full stack solutions for their verticals. So that was something I really wanted to do. That was something I got to do as a data scientist, but I was looking to get even more full stack, right? I wanted to be the one building the platform tools in the end, and that's why I made the transition.
Okay, so you're now on the platform side. You're building the tools for the full stack data scientists.
Right. Specifically, I work on our in-house experimentation platform.
Yeah, from experimental particle physics to experimentation. I love it. So Brian, we're super excited to have you, and you work at Stitch Fix. They have lots of really rich data problems, right? You use algorithms and also stylists to help match people's clothing preferences, their physical build, their price ranges, all into a perfect wardrobe. Can you give us a sense for how data helps you build better algorithms for your customers, or where else are you using data at Stitch Fix?
Data science from the beginning has been core to the Stitch Fix business model. So it's to this day really at the heart of everything that we do. So the entire business has some kind of algorithm behind it. So you can start with, say, merchandising, planning, and buying all the clothes that we need to buy, forecasting for that, demand modeling, even developing new styles. We use data science for that. And then you have things like operations, shipping logistics, inventory management. And then from there, it's the more sort of traditional data science that people might be familiar with. Of course, we have recommendation engine for our styling. The way that styling for fixes works is that we have an algorithm that will narrow down the inventory to a curated set. And then we have a human stylist at the end who always makes the final decision. And now, of course, we have data science behind lots of experimentation behind our client-facing website, which has been growing and expected to grow a lot more.
Yeah, so I love how experimentation is really at the heart of everything you do. I read that you made a decision a while back to switch from more ad hoc experimentation to a centralized platform that does all of Stitch Fix's experimentation. What drove that decision, and what are some of the benefits of having a centralized platform for experimentation?
Yeah, so the thing that happened was before we had an experimentation platform, data scientists were using all the other platform tools that we have to make their own experimentation tooling and frameworks, right? But the data scientists were often concerned about their specific vertical in the business. So you would get a lot of duplicated work, inconsistent ways of doing experiments, right? When that happens as a platform team, we try to be really aware of that kind of thing. And that's a signal that it's time for us to generalize what we have into a single centralized tool that everybody can use across the whole business. That was actually the decision that was made before I started, but that's the history there.
I was going to say, Brian, with the chronology there, Stitch Fix had been around for quite some time and had, I assume, done many, many experiments prior to investing in this platform. So it's clearly possible to do the work without this type of investment, but I assume that you can clearly see a difference in like the pre and post world.
The pre-world is actually before my time, so
sure.
I don't have a personal firsthand knowledge, but from what I understand, it's a much better system that we have now. Data scientists like it. I mean, a big advantage is you don't have to be an expert to use it. So we have engineers who are not statistics experts, and we have product managers who can set up and run useful, valuable, valid experiments using our platform as well.
Yeah, it feels like with experimentation, one of the hardest parts to get right is isolation. And if you don't know what else is happening in your org, or you're not aware of other teams' experiments, you might accidentally introduce some false information into the experiment. So centralized feels like a good approach, but many teams that don't have all the resources might not be able to invest in such a centralized platform.
Yeah, that's a good point. I mean, we have a big platform team. So for us, the choice is often pretty easy. We like to build stuff in-house. So
what's big look like right now for you folks?
I don't know the exact number of people on the platform team, but we have the whole algorithms org is around 150, and that includes platform and data science.
Cool. So we're going to get into the meat of the episode. You wrote this amazing article about multi-armed bandits, and it was one of our most popular articles that was read on Tristan's Roundup. And why don't we get into a high level? Like, what is a multi-armed bandit? Why is it useful? How do you use them at Stitch Fix? And we'll go from there.
A multi-armed bandit is an algorithm to experimentally discover the highest ROI choice among a set of possible choices that all have some kind of random output. So the classic example, and the reason it has the name multi-armed bandit that people talk about, is if you had a bunch of slot machines and you have a limited amount of money that you can put into these machines, and your goal is to figure out which machine on average pays out the highest, while at the same time spending as little money as possible, right? So the multi-armed bandit helps you trade off between the exploration that's needed to gather evidence about each of the options, trade off the exploration with the exploit side, which is you want to maximize your winnings by picking the one that seems to be the best.
Yeah. So it sounds a lot like classic optimization problem where you have a reward that you're trying to optimize for. You have a set of decisions that you can make. Mm-hmm. And the multi-armed bandit algorithm lets you explore a lot of different options in effort to increase your reward or maximize your reward. Is that a fair kind of read back of what we're talking about?
Yeah, I think it's maybe a little more than optimization problem. I would even say it's kind of the first maybe introductory reinforcement learning problem, where you're incorporating feedback from some system that you're interacting with in order to improve your model as you go.
And what does that look like in practice at Stitch Fix? Is this something that you've implemented for lots of different problems that you have, or are there ones that you can talk about with our audience?
Yeah, definitely. So recently we started using multi-armed bandit for landing page optimization. This was actually a pretty big win. We just had the results announced about a week ago. So the idea is when a visitor comes to stitchfix.com through some external source, say they click on an ad, right, for Stitch Fix, the first page that we show them is probably going to have a pretty big impact on how they perceive our brand and how they interact with us. So we had a huge variety of options for these landing pages, lots of different creatives that we could be using, and we needed a way to figure out which one is best. And so because we had a big variety of options, and because the traffic rate that we get is not, it's not like Google or Facebook scale we're talking about here. We have a limited amount of data to work with and a big variety of options to try out. A multi-armed bandit really became the right choice for this problem.
My experience with experimentation has always been this real challenge to adequately power experiments. Mm-hmm. And that's exactly what you were just getting to. Does the multi-armed bandit approach allow you to power a larger set of options?
Well, it's difficult to talk about power in the context of multi-armed bandits. You don't get to do a power calculation as you would with an A/B test. So it's hard to compare the two. There are situations where a multi-armed bandit is going to be preferable over an A/B test. There's, of course, a trade-off, right? So depending on what algorithm you use, there may be different guarantees about convergence. So just like in an A/B test, you have a chance of a false positive. In a multi-armed bandit, you could converge to a suboptimal variant. It's possible. It's harder to quantify that with a multi-armed bandit than it is with an A/B test. And the other risk is if you have non-stationarity. So we're kind of in a bandit, you're incorporating all this evidence as you go and building upon it. And you're kind of assuming that the average reward for all your arms is going to stay the same over time. If there is a change while you're doing this in the reward from some action, your bandit may not be able to account for that because it's got all this accumulated evidence so far, and that's hard to overcome.
Yeah, that's so interesting, like the false start problem, right? So in your example of landing pages, I imagine you're trying out a bunch of different landing pages. If it leads to more revenue, maybe that's your reward. You'll start funneling more traffic towards those landing pages that are successful. What do you do about false starts, right? You've sent a lot of the traffic to a landing page, which looks really promising. So you keep sending more and more, but you end up at this local maxima versus a global maxima. Is that often a problem, or how do you correct for that false start problem?
So there's a few ways you can handle that. The first is by choosing the right strategy for selecting arms. So Thompson sampling is the one we use for this particular experiment, and it sort of naturally handles this for you as you go, right? So in the early part of the experiment, you don't have much data. The way Thompson sampling works is it'll tend to select more randomly in the early stages, and then as you go through the experiment and collect more evidence, the bandit will naturally tend to start preferring the ones that appear to be better more often, selecting them more often. So it does take into account the amount of evidence that you have. So that helps. You can also, something we haven't done, but I think is an interesting idea, is to kind of stack bandits. So you could have something like Thompson sampling, which could converge, but you want to make sure you're still doing a little bit of exploring even after you seem to have converged. So you could add in a little bit of epsilon greedy in there just to make sure you're still picking the other arms at random, for example.
Changing topics a tiny bit, I've read about TikTok's algorithm and how anytime they show a user's video, when you first see it, they show it equally to the first 100 people, and they don't pretend to know if it's interesting or not. And then if people engage with it or like it, then they start showing it to more and more of the audience. And that's how they maximize the reward of people staying on the platform. But it feels pretty similar to how they approach it.
Yeah, that sounds like a bandit or a Bayesian kind of approach to me.
One of the things as we're talking about this, and I can't help but like have my mind go to, is that there's this kind of inherent trade-off between algorithmic complexity and the challenge around communication to business stakeholders, or really throughout the organization. I mean, this is not so different than when you start talking about neural network explainability. I think that many folks on the business side in tech companies today are familiar with talking about the experimental process for A/B testing. How does it actually sound to talk about, in a business context, the results of a multi-arm bandit experiment? Like, you're probably not saying, like, we have a 95% confidence that. How does that conversation sound?
That's a good question. I mean, I haven't personally been in those conversations because in my role as a platform engineer, I'm sort of abstracted away from a lot of the individual use cases.
Sure.
But I can say for this recent bandit we did for the landing page optimization, it was also done. We did an A/B test to test the bandit as well. So there was a holdout group that was not even exposed to the bandit at all. And then we can show what business partners are used to, the kind of classic A/B test p-value of how the bandit does versus a baseline solution.
That's super interesting. Never would have anticipated that answer. That's cool.
That's a good segue into A/B testing, because that feels most familiar to people, but a lot of times A/B tests can be mismanaged or done wrong. Do you have some tips of the trade on how to run a really good A/B test? And I have some thoughts there too. So I'll let you kick it off though.
Yeah. So A/B testing, it's hard to get right. It's one of those things where it's really easy. And like a lot of things in data science, I think it's really easy to fool yourself. And so a lot of things are in place to prevent you from fooling yourself. So an important thing to do in advance, you need to know, number one, what your hypothesis is. And from there, you need to do a power calculation. So you need to set your sample size in advance. And that has to be part of your experimental plan. That's pretty important. And then, of course, you need to know what your outcome metric is that you're going to analyze in the end. And all of that has to be fixed in advance, that might sound basic, but getting that as a standard way of doing things for the business as a culture can be a challenge.
That is putting it mildly. I feel like the number of people who don't determine their sample size at the outset is above 50%.
Yeah. So in the platform, we try to make that as easy as possible for people. So recently we built a sample size calculator tool into the UI, so that when people go to run their experiments, they can actually pull up the power calculator first And it's based on, now that we've had this platform running for a few years, we can base this analysis, automated analysis, on that historical experimental data. So we know what baseline numbers are for different outcome metrics, and what, and people can put in what their expected effect sizes would be, and we can tell them what sample size they need.
Yeah, it feels like it's a hard problem to get right for something that sounds really simple. And it's because it's hard to isolate things in practice when you're dealing with complicated businesses or real life problems. You almost can never run perfect A/B tests where you've removed any potential outside influences on the experimentation you're trying to run. So I've always been curious why there hasn't been a better like A/B test software approach. Like Optimizely was a company that had a long run, but it almost feels like the interpretation piece is the hardest because it's impossible to just click a button, A/B test, and it all works. And so I think there often is needed data expertise to interpret the results far more so than people would hope in A/B tests.
Yeah, absolutely. I agree with that. We can do some amount of automated analytics in our platform. And, people do use it to make decisions, but very often, a surprising number of A/B tests are not standard A/B tests. And there's always some extra consideration that has to go into the analysis to make sure we're getting it right.
I think about things a lot of times in terms of stages. My career has been spent at startups from a variety of like micro to modest scale stages. And there's partially because of the wave of tooling that Optimizely was one of those companies. There's this almost like religious belief in growth marketing and all of the like experimental work as a part of the toolkit of every company out there, regardless of size. A lot of the way that you folks do this, you could not scale this down to a company of 20 humans who are all trying to just like hack it together. Do you think, and this is really a question for everybody, I honestly don't know what I think on this topic, but is there an appropriate scale of company where you can start doing this type of work?
I know. I think it's a hard question to get right. It's not so much number of people, so much as like how much data do you have, or like how many users do you have,
but also like the willingness to like invest in data headcount, right? The expertise to interpret it.
I think experimentation came around as a category as software became easier to ship, right? Because you can run these cheap experiments, you put something out in the world, change it quickly, measure it. You can't do that with physical goods. You can't do that with things that require a lot of resources or people intensive problems. I think of it more as exactly what I said before. It's not like how many people can you apply to solve this problem, but how much data are you working with and how easily configurable is your experiment, or how risky is it actually to test things out?
Brian, any thoughts? Happy for you to pass if this doesn't feel like you've only operated at very large scale, I think, right?
Yeah, I've never been at a really early stage startup,
sure.
So I don't know what that experience would be like. But I can imagine some amount of A/B testing can always be done from early on. I think, like you mentioned, Optimizely, there are plenty of other tools for testing that you can, third-party tools. You don't have to build everything yourself from early on. And one data scientist can help a lot with like the learning how to A/B test correctly.
Yeah, that's fair. I think it's maybe the missing ingredient that a lot of small companies don't have, that I've seen at least, is executive buy-in to run the scientific process, quote unquote, the right way.
Yeah.
Because I think that especially in the early stages of companies, there's so much pressure to move and deploy things to production. And sometimes doing the process the right way, the answer that you get is actually like, well, we don't know. And we're not going to move forwards. And it's so hard to fight that impetus of like, no, ship it.
I think another big blocker too is the impact to the business, right? If you have an hypothesis that this will be better, or this will be worse, running an experiment you're sending half your traffic to what you think will be the worst outcome. So that also provides a lot of, I think, roadblocks in doing experimentation, especially for enterprise or B2B. When you have so few customers or they're paying you revenue, the stakes are so much higher to run experiments on them versus when you're dealing with thousands, millions of users, and your reward is time spent on an app versus dollars.
Potentially one of the most convincing things that could happen for someone who isn't convinced by experimentation is to is to do an A/B test and have a really bad result from the test, right? Something that you catch because you did the test that you might not have caught if you just decided to put it in production without testing. And then you can learn that A/B testing is actually can be a way to help you speed up, because if everything is automated and you A/B test everything, you can make sure that only the good things get out there, and you don't have to think about it, and you don't have to worry too much about things going wrong.
So I've been hearing a fair amount about what I think is almost like the next iteration of experimentation, which is causal inference. And basically it instead of having to have a hypothesis of what influences what, you can do some data science voodoo to figure out causal relationships versus just correlation. And that really is the hardest problem I can imagine someone trying to solve. Have you come across this at all, Brian? Or what do you think about causal inference? Is it magic or something, a tool that people will be able to use to help figure out causation versus just correlation?
I have heard some data scientists at Stitch Fix kind of excited about causal inference. I've heard some people talk about it, but I don't know much about actual use cases. I'm not really the expert in causal inference.
I got super interested in this topic when Judea Pearl's book came out. It's called The Book of Why. I actually have a copy of it. I think it's probably still sitting on my bedside table, and I just couldn't get through the math. And if you hear Judea or other folks in this group talk about causal inference, if you're doing what is commonly known as typical statistics today, they make all of us feel like complete idiots for not being able to truly assess causation. But I find myself unable to evaluate the arguments at a technical depth that I would need in order to know is this really true? Have we been getting it wrong for 50 plus years? And there's a new way to do it. Julia, I completely agree that it is exciting. And if there's a better way to do that, where you can look retrospectively instead of needing to design an experiment to assess causality, it certainly would be very powerful.
Yeah, I have some very smart friends in research departments at large organizations like Netflix and Microsoft. And I have to believe that this is what they do all day long, actually, like causal inference where it really matters. And I just have to trust that they know something about the data that I can't interpret myself. But I do think it's an interesting space. I've also been noticing some startups popping up to try to bring causal inference to the masses. So ClearBrain, that was a company that was bought by Amplitude a year ago. Actually, the team came out of Optimizely. So as you could see that journey going from A/B test to causal inference, and now it's a part of Amplitude. There's another early stage company called Table AI and Sisu Data, which try to bring these relationships to bear in the data, and they believe they can prove causation, not just correlation. So I think we'll hear more about it in the months and years to come, but it does feel like a really cool new emerging space.
Hey everyone, just dropping in to let you know that the annual Analytics Engineering Conference, Coalesce, is back. We had the first Coalesce last year in December, and it was fantastic. We had 3,000 registrants, tons of presentations, and this year is going to be even bigger. Register for free at coalesce.getdbt.com. We were talking about powering experiments before, and we talked about TikTok and how you can just use the first 100 impressions to seed the algorithm. B2B companies, and I've worked at B2B companies now for 10 plus years, B2B companies are in this rough spot where you almost never have enough traffic, especially on the sales and marketing end of the funnel. Maybe once you get into the product, there's enough existing usage where you can start doing this stuff. But if you're trying to do sales and marketing experiments, you just don't have a lot of a sample size to work with. Do you have advice on what to do in small n instances?
There's a couple of things you can do. I mean, you can do A/B tests and just reduce your power requirements by a lot, with the idea that, we don't actually care that much if being underpowered, as some people argue, is not that big of a deal. If you're looking for big effects, or if you're just trying a lot of different things, it may not be a problem. And if you have false positives, you could even argue that that's also not a big problem, right? And that 5% threshold that people always say for false positive rate is pretty arbitrary. And depending on how much risk you're willing to take, you can play with that quite a lot. And then, of course, multi-arm bandits, we already mentioned before, another way to get more out of a limited amount of data, which is pretty important at Stitch Fix as well. Like I mentioned, we're not huge scale like Google or Facebook. The things we're experimenting on, our experiments, we're often experimenting on shipments, which, take a couple weeks to turn around and get outcome metrics on. So it's pretty common for us to have an experiment that lasts months.
That's so interesting. It's not a problem for you to imagine that there will only be sample sizes of in the hundreds.
With shipments that are, our shipment counts are pretty big. So we can still have hundreds of thousands or millions.
Sure.
But it can take a long time to get there, right?
Yeah.
And yeah, if you do have limited sample size, a bandit, especially for something like marketing, I think could be a really valuable thing to use.
How about synthetic data or simulations? Does that at all come into play at Stitch Fix, and how you could potentially increase your experimentation size or test things out that have high risks that you don't want to put into place in the real world?
Julia, can you explain how does that work? I've never heard of that tactic before.
Instead of actually applying this to a customer or user, you have algorithms that recreate potential outcomes or potential patterns or usage for different users. And then instead of testing it in the real world, you just run simulations. I have synthetic million users, whatever I need to make the algorithm work. And sometimes when you have small and sample size, you can create larger populations by just randomly creating the attributes in software.
Yeah. So we do simulations for certain things at Stitch Fix. So for example, if you want to test out different buying strategies, so talking about buying wholesale clothes, you can't really do an experiment. You make the decision once about what you're going to buy, right? And it has some impact on the inventory and potentially on the demand. So what we can do for that is we can model the Stitch Fix inventory. It's a pretty complicated dynamical system, so it's difficult to simulate correctly. And of course, when ways of operating in the business change, the simulation has to change as well to try to keep up with it. So that can be a really big challenge, but that can be useful to test out different scenarios of what we might consider buying to add to our inventory. That's another case where the turnaround time on something in a real experiment could be very long. So buying clothes is a really slow process. It often takes months to receive your shipment that you ordered. So you're trying to forecast both the state of your own inventory and the demand for that inventory really pretty far into the future, and try to reconcile those when you place orders. So simulation can help with that, but the error bars can be quite large. So it's challenging to measure the impact and the value add there.
I kind of want to pivot off of one of the things that Julia said a little bit ago. You have a very sophisticated team there. At the very beginning of our conversation, you talked about where Stitch Fix is using data, and you kind of described the entire org chart.
Yeah.
It's like not clear that there are parts of the company that don't make pretty extensive use of data. Do you think are you living in the future? Like, is this just how companies are going to work? Or is there something unique about Stitch Fix that allows it to operate this way, and that's different?
Having been at Stitch Fix for 3 years now, I sort of get used to this culture where I don't even think about it as something special anymore.
Yeah. This is not normal.
Yeah, exactly. I have to remind myself, like, I'm pretty lucky to be at a company that values data science so much, and where it's such a key part of everything we do. Because I talk to people at other companies and I hear about where they are in comparison to where we are, and we can be leaps and bounds ahead, which is pretty great. So I think it's unusual. I think it's great for the business, and I think if you can get that seed in the beginning, early on, of that data culture, it can be unbelievably valuable.
I feel like there must be something that gets baked in from kind of the ground up. I feel like I've heard interviews before with your founder where she talks about this as kind of a founding idea of the company.
Eric Colson, our former chief algorithms officer, he was there from very early on, and they made a pretty strong commitment from those days to be a data-driven, algorithm-centric company. And even having the head of data science at C-level was a pretty big deal. It was a pretty new thing at the time, so that was pretty important.
Yeah, it seems like it's the thesis of the company, right? we can tell you your preferences better than you can. And actually, not only that, but if you have a preference, we can probably improve it. We can get you to like something stylistically that you haven't explored before, but you're going to end up wanting and enjoying. So it has to be from the foundations built into every kind of decision you make. Data algorithms. It's really cool to see.
Yeah, exactly. Every interaction with Stitch Fix should feel personalized from the first landing page you land on to the first fix you order. Everything should feel like it's for you. I think that's what we're going for.
So we're going to wrap up the episode with a question that we ask all of our guests. Looking 10 years out, what do you hope will be true for the data industry?
What I think people, data scientists and engineers in general, need to start caring more about the impact of their work. I think it's something that's really not focused on much. People care a lot about the what you can do and how you can do it, and less about like if you should be doing it, what the broader impact your work can have on the people using your software or just on society in general. So I do see some signs that people are aware of this and care about it, but I hope that continues to grow over the next 10 years.
You could probably say similar things about academia, where there's kind of academics have gone very increasingly narrow over, the past few decades. And now there's this push to become more generalist, to talk more about impacts, to think cross-functionally.
That's an interesting debate, I think, in academia of,
Sure.
Whether academics have responsibility to the public. So at least from my experience, most academics would say probably not. They're focused on their work, and their responsibility is to their research, because they view the work they do, at least in science, it's about advancing human knowledge for posterity. And, that's the goal, right? But I think there has to be a little bit more responsibility, right? Because if you're going to argue that your research is for the benefit of society, but actually it's not benefiting anyone because it hasn't been communicated, or people are not being educated correctly to understand it, or to get the value out of it, then that's maybe that is a responsibility of academics as well.
I'm reminded of this great book, Complexity, by Mitchell Waldorf, which talks about the Santa Fe Institute. And it was a collection of computer science engineers, economists, biologists, physicists that got together at the Santa Fe Institute that took their domain knowledge and actually figured out how to apply it to real world problems. And a lot of machine learning, the early beginnings of machine learning came out of that group. So I think that hope is actually a really good one. And there's still a lot more work to be done.
Absolutely.
Brian, thanks so much for hanging out with us today. If listeners want to find more about you, where can they go?
Yeah, you can find me on Twitter at Brian Amadio, or you can find my work on GitHub, github.com/BT Amadio.
Perfect. Thanks so much.
Okay, thanks for having me.
Thanks so much. The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.